Hi everyone, welcome back to the channel. Today we're diving into an important skill in chemistry called completing chemical reactions. Whether you're just starting out or brushing up before a big test, this lesson will help you recognize reaction patterns and predict the products with confidence. We'll walk through 5 major types of reactions that you must know: composition, also known as synthesis, decompositions, single replacement, double replacement, and combustion. I'll show you how each reaction works, what clues to look for, and how to complete the products correctly. By the end of this video, you'll be able to look at a reactant pair and immediately predict what's going to happen. Let's get started with a synthesis or a composition reaction. Here we have two things combined to make one thing. These are real easy when you have something on the left side reacting with something on the right side, a metal and a nonmetal. The first example here, we have sodium plus chlorine. So that's going to react to form sodium chloride. Okay, and to balance this, let's put a 2 here and a 2 here. Magnesium and nitrogen. I know that magnesium is going to be a 2 plus. I know that nitrogen will be a 3 negative. So I would have 3 here, 2 there. And then to balance it, I would go 3 here, and okay, it looks balanced. And we generally take off these charges here. That's just to help us. Sodium plus elemental sulfur. So I know that sodium is going to be a +1, and that sulfide is a -2. All right, so this is going to form Na2S. And then we'll just balance this. So I need 8 sulfur, so put an 8 here and 16 here. Okay, here I'm including an activity series of elements. This order may be slightly different from what you see in other textbooks. It depends upon if this activity is measured as reaction with cold water, or maybe through some electrochemical process. But this is the one we'll be using today. The more active metals are at the top, the less active metals are on the bottom. All right, so for synthesis reaction. Okay, metal plus oxygen. If a metal is more active than silver, it will react with oxygen to form a metallic oxide. If the metals with an activity of silver or lower, it will form oxides indirectly. Okay, so magnesium plus oxygen would give us magnesium oxide. And we'll balance it. All right, zinc plus oxygen give us zinc oxide. Okay, again. All right, silver plus, okay, silver is, if you'll look, okay, silver is down here. So these do not react directly. So I'm going to put no reactions on NR, which stands for no reaction. A nonmetal plus oxygen, those are fairly easy. Metallic oxides plus water will produce a metallic hydroxide, so the metal is barium. So it's going to be barium hydroxide. So I have 1 barium, 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens. It's balanced. Okay, a nonmetallic oxide plus water. Okay, so here's the trick with this one. If this has 3 O's, when you react it with water, just add another O to it. So it's going to be H2SO4. So SO3 becomes SO4. Okay, so everything else looks good. A nonmetallic oxide is also known as an acid anhydride. A metallic oxide is known as a basic anhydride. So here I have a basic anhydride with an acid anhydride. It basically means a base without water plus an acid without water is going to make salt. And this salt will be BaSO4. Ammonia plus an acid will yield an ammonium salt of the acid. So the ammonia will become ammonium chloride, like this. Metallic carbonates, when heated, will form metallic oxide and carbon dioxide. All right, so calcium is the middle. So it's going to form a metallic oxide, so it'll be CaO plus carbon dioxide, CO2. There is an exception to this rule, and that is ammonium carbonate. So ammonium carbonate, when it's heated, it's going to form ammonia plus water plus carbon dioxide. And let's put a 2 here to balance it. Metallic hydroxides, when heated, form metallic oxides and water. So that'll form barium oxide plus water. Now there's 2 common exceptions to this rule. So if this were sodium hydroxide or potassium hydroxide, if I heat either one of those, no reaction. They're too stable to decompose upon heating. Metallic chlorates, when heated, produce metallic chlorides and oxygen. So potassium chlorate will produce potassium chloride plus oxygen gas. And this would be a 2, 2, and 3 to balance it. Some acids, when heated, produce nonmetallic oxides and water. So if I were to heat sulfuric acid, I would get a nonmetallic oxide. So I'm going to reduce this number of O's by 1. So it's going to be SO3 plus H2O. Some oxides, when heated, decompose. Only the oxides of metals less active than copper will decompose upon heating in air, and those less active than chromium in a reducing atmosphere of hydrogen. Silver is below the threshold, so it will decompose into silver plus oxygen. Okay, so I put 4 there. Copper falls between magnesium and chromium. It will decompose in a reducing atmosphere of hydrogen. So it's going to give me copper and water. Electrolysis is using electricity to separate compounds. So this is going to form hydrogen plus oxygen. Single replacement reactions are usually pretty simple to spot because I have something by itself combining with a compound. This potassium here is going to try to displace the calcium here. If the potassium is more reactive than calcium, then it will replace it. I'll look on my activity series, and potassium is located higher than calcium, so therefore it will replace it. So it's going to form potassium nitrate plus calcium. And I see I forgot a 2 there. Let's fix that. So I need a 2 here and a 2 there. All right, lead plus zinc chlorate. I find lead and I look for zinc. Lead is pretty low on the table here, and zinc is about midway. So therefore, lead is below zinc. Therefore, it will not replace the zinc, so we'll write no reaction. Metals plus water. If the metal is more active than magnesium, it will form a metallic hydroxide. So just make some notes here. So these plus water will yield a metallic hydroxide. If these are with water in the form of steam, then it will form a metallic oxide. These plus water, no reaction. Sodium is above the line, the first line, so sodium plus water will form sodium hydroxide plus hydrogen gas. All right, zinc plus water in the form of steam. This will form a metallic oxide plus hydrogen. Copper is below the line, so it's less active than iron, therefore no reaction for it. So repeating the rule one more time, if a metal is more active than magnesium, a metallic hydroxide plus hydrogen is formed. If the metal's activity is between magnesium and iron, a metallic oxide plus hydrogen gas is formed if the water is in the form of steam. If the metal's activity is less than iron, no reaction is formed. If I add an acid and a metal together, it's going to form salt plus hydrogen gas, with any metal more active than hydrogen, assuming that the acid is not nitric acid. Zinc plus hydrochloric acid is going to make zinc chloride plus hydrogen gas. For halogens, the halogen can replace another halogen if it is more reactive. Bromine is lower than chlorine on our table, so therefore bromine cannot replace chlorine, so we'll put no reaction. And the last one, chlorine plus potassium iodide. Chlorine is more active than iodide, so it's going to form potassium chloride plus iodine. For my first double displacement, where they just switch partners, okay, so the metal nonmetal plus metal nonmetal, so the metal here goes with this nonmetal, and these two go together like this to form AD and CB. So we'll start with an acid plus a base. It gives me salt plus water. So the salt will be sodium chloride plus water. In the second example, an acid and a basic anhydride. So it's going to form the salt, which is barium chloride plus water. And the third one, I have an acid anhydride plus a base. So that's going to give me salt plus water. This one's a little tricky. Okay, the salt is going to be sodium sulfate plus water. What happens is this number here will increase by 1. Okay, so I have a salt plus an acid. It's going to yield another salt and another acid. So it's going to be barium chloride plus sodium nitrate salt plus a base will give you salt plus another base. So the salt will be sodium nitrate, and the base will be calcium hydroxide. Salt plus salt will just yield another salt plus salt. So that's going to be now we're not doing solubility rules and showing all the aqueous and precipitates and all those things. We'll do that later on when we cover net ionic equations. But right now we're just basically trying to see what happens when things combine to form new compounds. Okay, metallic carbonates and acids is going to give you salt, water, and fizz. So the salt here will be calcium chloride plus water, and the fizz is going to be carbon dioxide gas. These three are a little bit more difficult than the rest of them. An acid plus a sulfite will form a sulfurous acid, which will further break down into sulfur dioxide and water. So the salt is going to be sodium chloride plus sulfur dioxide plus water. You may have it written like this, but this is unstable and it's going to further decompose to form these two. Same thing up here. This will be H2CO3, which is considered unstable on the right side, so it's going to further decompose. If I have an ammonium salt with a base, it's going to form a salt plus ammonium hydroxide. So this is going to give me calcium sulfate ammonium hydroxide is going to further decompose to give me ammonia plus water. Let's put a 2 here, a 2 here, and there's a 2 should go there. Okay, for combustion, I'm only going to consider the combustion of hydrocarbons for this category. If I have something with C's and H's, or C's, H's, and O's plus O2, it's always going to yield carbon dioxide and water. Okay, so I need 10 here, 8, so I'll put a 4, and 20, that'll be 12 here. And the last one, C's, H's, and O's, is going to form carbon dioxide and water. So I have 2 carbons. I need 6 H's, so I'll put a 3 here. I have 3, 4, 7 oxygens. 6 and 1 is 7 oxygens. And that's it for completing chemical reactions. Now you've seen how to identify and predict products for composition, decomposition, single replacement, double replacement, and combustion reactions. With practice, these patterns will start to come naturally. If this video helped you, make sure to like and subscribe and share it. Thanks for watching, and I'll see you in the next video.